Okay, so this is problem number 7. Okay, so what I'm going to do is start out with a single statement. I could use not M, with not M implies T. I could use these two together. The only thing I couldn't use is something that had F or S in it that was embedded in the compound hypothesis. So I could either start with these two or with these two. So I'm going to start with,
Can you point to those three?
yes,
Start with these.
second and third one, or fourth and fifth one. So I'm going to start out with not M implies T together with not M. However, when I put it in to my proof, I always consistently want to start with a single statement. But I like to show them with the conditional on top and then the single statement because I think it looks better or easier for you to understand. But I'm going to put not M in first, which is given. And then not M implies T, which is also given. Now, putting these two together, the hypothesis of this conditional is true. Therefore, the conclusion must be true as well, because otherwise, T implies F would have been a false conditional. So my conclusion is T. What's the reason? Modus ponens. And you need to put the line numbers that got you that solution, which is lines 1 and 2. Now I want to go to something that has T in it. So I'm going to go to, I've used this one and I've used this one now. I'm going to go to the top line, which is F and not S implies not T together with T. This is a conditional of which the negation of the conclusion is true. Therefore, the negation of the hypothesis is true because it's the contrapositive of the original. And the contrapositive is logically equivalent to the conditional. And the reason is modus tollens. So I'm going to bring in F and not S implies not T. And I'm putting that together with T, arriving at the conclusion of the negation of the hypothesis, which is not then the parenthesis F and not S. I don't actually get rid of those parentheses now. I just write the negation of the hypothesis because the reason for that is modus tollens. To simplify it is a different reason. And modus tollens is lines 3 and 4. To actually get rid of the parenthesis, that is to simplify the negation of a conjunction, that's De Morgan's. That's a separate reason. And we get not F, an and becomes an or, and not S becomes S. And that's by De Morgan's. On line 5 only. Now, there's nothing I can do with that right now. I need to work on not F implies W, so I'm just going to let that stay for a minute, number 6, leave it alone, and go to, this is a conditional, not F implies W together with not W. This is a conditional. The negation of the conclusion is true. That's not W. Therefore, the negation of the hypothesis, which is F, is true, because not W implies F is the contrapositive of the original. So I'm going to bring in not F implies W. That's given. I'm going to bring in not W, and that's given. Then I'm going to put these two together. The negation of the conclusion means the negation of the hypothesis, which is F. By modus tollens. Lines 7 and 8. Now remember I left, yes.
Does the order for 7 and 8 matter? Like if you put not W first?
No,
Okay.
7 and 8 could be reversed.
Yes, you're saying?
Yes. Number 6 is not F or S. Number 9 is F. This is a disjunction. F is true. Not F is false. For the disjunction to be true, one or both of them must be true. If it's not F is false, then it must be S that's true, which is exactly what you were supposed to be proving. So I'm going to put 6 and 9 together and get S by disjunctive inference. And lines 6 and 9 together.